Hello, this is Sean Thomas, and today I'm going to go over my final graphics project with my team, which is called Bullet Hell, and it is a final project for our graphics class. So now I'm going to play the video of our project. As you can see, that's our project, and my main contribution to that was getting the rendering working with the textures, as well as getting the lighting working to add more depth and, I guess, shininess to the bullets and to make them look nicer. Essentially. So now I'm going to walk through my contribution to the code. So here, this first thing that happens here is we pretty much create a window here, and we add an anti-aliasing, which is this part right here with 4. Then this essentially creates a window with a width and height that's predefined, and we have this little inside joke as our Windows header, um, and then just some layer handling for if the window doesn't open. Then we make the window the active context, and we enable multi-sampling for smoother rendering. So that happens right here inside of this gl11.gl enable. And first we create the capabilities for GL right here, and we again make the current window we give the window the current context. Here is where we add the background to give it the feeling of I guess hell from Bullet Hell. And then here we start adding in 2D texture mapping, so the surfaces can display the image-based textures. So we use gl11.gl enable the texture 2D from other gl11. And then here we enable the lighting system for the reflections that are on the bullets. So we enable it here, and then we choose the type that we want, which is the light 0. And then here we decide where we want it right here. And here's where we create the buffer to start adding the positions for the light. And then we add that to our G11 right here to configure it. So here's pretty much the base color that gives like a yellowish kind of hue. We create the buffer for that, and then we put in our values we want to the buffer. Then we add that into our GL light V FV right here. And then we add the shine color to the bullets, which is the white, as you can see on the outside of the bullets. And again, we create a new buffer. We add in the values to our buffer right here. And then we update our G11 again with those buffer values to give our bullets that metallic white hue. And then we have ambient lights as well, based on the lighting. And again, it's pretty much similar process. We create a buffer, we put in the values we want into the buffer, and then we add that to our G11 GeoLight FE. And then we add smoother shading across the triangles by shading the model using the GL11. And then we enable that right here. And then after run using all of that, we pretty much want to clear that and then load it again so it's completely new. We can do this all over again. And then here's where we pretty much enable the colors. That happens here as well. And then we render the terrain. And then here we push the buffers to the window, and then we're just looking for any events. although I don't think we're actually using any input from the events that are happening inside the window. Um, so here are some pretty much just some static variables that are used inside of the scene. We have max bullets of 160. We have a spawn rate of 18, fall speed of 18, and spawn height of 200. And then here we have a tick counter so that bullets can spawn evenly and the tick gets updated. And then we have these values, I guess, are for the window or for the dimensions or for the space the bullets can be in. And then here is just here we have values for the textures that can go in the small or large bullet. Um, and then this is just the terrain. So what happens here is we have a texture loader that loads the small bullet and large bullet PNGs and saves them to these static variables. Um, and what happens in here is we have a spawn accumulator. Um, so it just pretty much tracks the bullets that are being spawned and spawns a bullet and then decrements the accumulator while increasing it up here so the bullets can infinitely spawn but have a max of 160 bullets. Here's the spawn bullet function. What happens is we have the max X and min X and max Z and min Z determine where the bullet can be placed, and then it'll spawn it there. And then here we determine if it's going to be large or not. And then I guess right here we have the angle that's going to be at, or not angle, but I guess horizontal drift is what it says. And then we add it to the list of active bullets. And then here's our render function. So we enable the lighting that we need and the material. I believe we're using the same one as before. And then we create our buffers, and then we add in our the same color that we were using earlier for the white shine on the bullets. And then we're using this material, which is created from the buffer. So the buffer is created here, and we put the material in there, and then we push it into here. And then we set the shininess that we want, so it looks like the metal is polished and looks nice. And then we bind the texture here to the large bullet. So first we're making the texture by taking in the texture and then we're binding it to this, and then we render it here. And then that's the same concept for the small bullet as well. And then here we're getting rid of the matrix so that we can use it again. And then here we're adding the colored material again after we removed it. And then here's our bullet constructor. These are pretty much just the X, Y, and Z values, and if it's large or not, and then it's horizontal drift, pretty much. Here we have the UV texture coordinates. So essentially we're determining if it's what texture it is from the OBJ file. And then right here, we're pretty much determining the coordinates that the texture should be at based on the OBJ file. And that's pretty interesting that's happening here. The vertex normal index, if it's greater than 0, we as normal, and then we update the GL11 with it. And then again here, if it's above 0, we get its text coordinates, and then we update the GL11 with that as well. And then we get the vertices, and we add all the vertices to the GL11 so we can render it, and then we end the GL11. And then here are just some helper functions to get the vertices, get the normals, and get the faces. Here's our class texture loader. Right here, we have to get the next power of 2 pretty much because otherwise we're not able to universally use whatever PNG we wanted. That was an issue we ran into. Here we get the strings path. Here we're essentially just reading the image from the file that we have. and we get the width and height of the image. And then we just, again, scale it by the power of 2, so that we're able to use it. And then here we get the pixels and the RGB values so that we can put into our buffer right here. So we can put the pixels into the buffer. And then we're able to make the textures here, and then we can bind them to our Geo11. We can get the texture parameter here as well. And essentially, we're just creating the texture from the image that we're getting. And then right here, essentially what's happening, we're pushing the buffer to the matrix. We're pushing the matrix. And then here, we're just pretty much spawning the scale of the y-axis and fit everything on the terrain. And here, writing the texture to our terrain as well. And then we render it, and then clear the matrix so that it can be reused again. And I believe that's all the things that I want to show for my contributions. And that is everything I wanted to show for our final projects for graphics, Bullet Hell.